Hey everyone, today we are going to be modeling. No, not like walk, walk, walk. Not that modeling. The modeling we're going to be doing is with algebraic equations. The modeling I'm talking about is where we draw. Today we're going to be drawing what an equation looks like. Now, an equation has an equal sign. And what it basically is saying is right at that equal sign is the pin, like the point of a balance where things are perfectly balanced. So x plus 7 ends up being exactly equal to 13, and so that it's balanced, right? If it's not balanced, then it would tip one way or the other. Kind of like this, like these aren't equal. This is not an equation, is it? If it was, it would be perfectly balanced like this. Okay, so today when we do equations, we are going to have regular numbers and we're going to have variables. We're going to draw them in different ways. If it is a long, skinny, if we have a variable, then we're going to draw it with a long, skinny line, rectangle. That's because we don't know if that x is a 1 or 10 or 57, right? Variables are unknown numbers. So we're just going to do a long, skinny one. And that's what it is, okay? Now, if we just have regular numbers, we're just going to say, well, that's 1, all right? Now, I am going to let my daughter take over because the experiment we're going to try today is, can you understand someone your age that's explaining it better than someone that's like old and out of touch with the real world, Mrs. Madsen? So, without further ado, here comes Miss Maia Madsen. And she is going to explain how we model one-step equations. Take it away, my dear.
Okay. So you explained everything?
Yeah, everything. They know everything. No.
Well, like
what I explained to them is that when we have an x, we can model that with a very long rectangle. When we have just regular numbers, we model them with squares. Okay? And so this right here shows x plus 6. This right here shows 9. And you can see they're perfectly level right there. That's because they are equal to each other.
Yes.
Okay? Okay. You good?
Mm-hmm. So on this one, pretty much whatever you do to one side, you have to go to the other side. So as you can see, they crossed out one right there. So that means we're going to cross out one right there.
And it will stay equal.
And it will stay equal because, let's say, let me go back. Let's say you just crossed out this one, and you didn't cross out that one. Would that be equal, or would it go lopsided?
It would totally go lopsided. So like this, right? If we just took out 5, would it be equal? Would it be lopsided? It'd be totally lopsided, right? So what would you have to do to the other side?
You would have to cross out 5.
Now would we be back to being totally and completely balanced?
Yes, and it can also help you find the answer when you do that.
Oh, what do you mean?
So, like, we want to find the x, so then x equals 3, because we found out right there because there's 3 left.
And the only thing that's over here is x, right? X is isolated. It's completely by itself. And we only had 3 over here, and yet they were equal to each other. Got it? Is there a way you can check that to see if it's right?
Well, we're going to do, I like to subtract. 6 subtract 9, what will that equal? 3.
Okay.
Or you could do 6 plus 3, which equals 9.
Yeah. But before, where you said x equals 3, we'll just plug that in there and see if you get a true equation.
Okay, let's see.
Yeah, let's see.
Yep.
Perfect. Go for it.
Okay. So, this says 2x equals 6. How we would do that would be 2 boxes. like that because it's 2x, not 2 plus x equals 6. It's 2x equals 6. So we have the 2x equals, well, 1, 2, 5, 6. There's 2 other boxes, so we can go like this and this, and that would equal x equals 3, and we could do 3 plus 3 equals 6 to prove it.
You could prove it by plugging in the x right there.
So 2, how did I do both? So 2 times x equals like that. This one is just showing how they are even, right?
It's just showing exactly what you did.
Just showing that it's even. This one is just showing what I did, how I circled the boxes like that. Now we're gonna wait, what expression does the equation show? So we're gonna make an equation, right?
Mm-hmm. So it's already modeled for you. They already drew it. So now you're going back and you're putting it in as a word, as a math sentence, a math equation.
Okay. This is x, right? Because a long square is an x. So 1, wait.
X, you could say x or 1x.
1x plus 6 equals 7. How we could do that is we could circle, we could cross out all of these.
Because then your x is by itself.
And what we have to do to one side, we have to do to the other side. So then we're crossing out that, and we have 1 left. So x equals 1, which makes sense because 1 plus 6 equals 7, which is right there.
Better handwriting.
Okay. So now we're going to do this one again. We have 1, 2, 3, 4. So 4 x's. Let me write it down there. 4 x's equals 4, 8, 12, 16. And how we could do that is
divide up the 16 between all the x's.
So like this. And all of them have 1. So what is in one box or one circle? 4. So x equals 4, which is right here.
Yep.
Now we're going to model it, so we need to draw it. So we're going to model 2 plus x equals 6. How we would do that is go 2 blocks plus 1 long box equals 6 blocks, like that. How would we know what x is?
Let's get x by itself.
So we're going to cross out these.
So now that x is by itself,
we have 1, 2, 3, 4. So x equals 4, right?
Yep. Now you can check it. Put that 4 in for x right there.
Is that correct?
Totally.
Now we're going to do another modeling one, but make sure to look at the 3x because it's not 3 blocks. It's 3 long blocks like that. Equals 6. how would we do this? Oh, figured it out. So one group goes to there, one group goes to there.
So what does which
2.
Each x gets?
So 3 times 2 equals 6.
Okay, so what does x equal?
X equals 2. Now we're going to, instead of doing a model, we're going to actually write it down. So here's 1x. Oh, this is 1x, so we're going to do x plus...
Put an x there because it doesn't equal 1.
Oh, yeah. And then this is 4, so x plus 4 equals 7. How we could do that is we could cross out all of these, and we're left with 3. So x equals 3. This one has x, so 3 x's equals 3, which here you could just go like that. And x equals 1.
Good job.
So x plus 6 equals, 10. How you could do that is I would cross out all of these.
So you're isolating the x, getting an x by itself.
Yes. And then what are we left with? 4. So x equals 4. 4 plus 6 equals 10. So how my mom just said we isolated them. This is what we're talking about pretty much.
All right, and now, no, I want to get to where's the biggest problem?
You just skipped it.
Oh, perfect. Okay. Every time I do this, I always have students that when I ask them to model 2x plus 6, they draw this model. So this is not the correct 2x equals 6. Maia, will you explain why?
Why? It is because there are 2 x's and not 2 blocks, 1 x.
So what does this show? What did they end up modeling?
They ended up modeling pretty much 2 times...
No, 2.
Oh, wait,
an x. They modeled a 2 and they modeled an x together.
So plus x equals 6.
Yeah.
But we want to show 2 times.
That doesn't mean anything with modeling.
Oh, no.
You've got to show, if you wanted to show times, you have to show that you're going to see it how many times. So rewrite it, redraw it.
This is how we're going to redraw it. We're going to do 2x plus, 2x equals 6.
No, how do you draw 6?
And do you remember what you do to find what x is? I'm going to go like this, and that makes x equal 3. So 2 times 3 equals 6. Yes, it does.
Perfect. Thank you, Maia. So my biggest push this lesson is not that you know what x is. Those were easy problems. You knew like instantly, oh, x is 3, x is 2, x is 1, right? That's not the most important thing with this lesson. The most important thing with this lesson is that you can draw it using long squares for x's or variables and the little squares for the regular numbers. So work on that. That's how you're going to pass this lesson and be able to move on. Maia, I'm always awkward at the ending, so I'm going to let you finish this video.
Peace out.